So the first demo we use Node and Varnish. So we've got a Node.js version 5 and Varnish version 4.0, which is pretty old, and we've got a modified version of Node.js Goat, which is a security project where you can hack pretty everything in this application. So the thing I add is a user deletion, and we see that we can delete the user with the post. There's no CSRF protection on this post, only a cookie protection. So the exploits on Node.js will use the hidden transfer coding header to remove the 70 bytes body. We now have a second query, which is a post which is unterminated. You see the partial header. Another user query gets appended with the valid session and perform the post. If we look on the details of the exploit, we see that we send the partial query after the splitting issue, and the admin user will send a new query appended to this post query. Here's the way to perform some HTTP on the command line. The first step is simply to print a query. So this is just an output. We see a regular HTTP query, and then we pipe the query on a TCP/IP connection with netcat. You see netcat at the end with NC. So let's try it. And we had a regular HTTP communication, and we found that we were not connected. It's an anonymous query. We do it several times, so we've got a lot of splitting issues, and we've got a lot of unterminated queries waiting on the Node.js side between Varnish and Node.js. Let's try it. Okay, it's ready. And now we get the admin session, we request any page, and we made the delete. That's done. User was deleted. You can see it on the application log. A second demonstration. Here we've got Apache, we've got Nginx, which does nothing, and we've got pretty old version of Go, so we can use several flows on the Go reverse proxy. Here we look at the reverse proxy code in Go. It's a very simple reverse proxy. New synchronous reverse proxy, as you can see. So we can look at the sources. We've got this HTML page with two image links, and the second image is Chiwi2, and we can look at the file. It's a real image. You see, it's a binary file. You've got some binary on top, and you've got HTTP in the image exif data, and then the binary thing. We've got the attack.png image, which is just HTTP, and that's why it's something which does not work in the browser, because it's just HTTP, it's not an image. The second one is a real one, and HTTP is hidden in the exif data. So how to extract this data? We use the first flow here with the chunk transfer encoding, which reveals the second query. So it's a splitting issue, then the HTTP 0.9 issue, and the range error, which should not be applied on a 0.9 query. In details, we'll first have a splitting issue where the second query is revealed in Go, which perform range query on engineering. So this is a regular query, but the 0.9 trick made Go remove the headers. So now we've got something which looks like a new response, which is the wookie response. Then we've got an innocent user requesting anything, and we've got the TCP IP cache positioning thing, APG, which reveal the extra response. So we do it with SSL. Instead of Netcat, we'll use OpenSSL client. So the query is done, and the TCP IP connection now poisoned on the APG side. We wait several seconds to be sure to get a new connection, and that's it. We get the wrong response for our queries. It works.